Have you ever wondered how vast and mysterious our universe really is? It's a question that has sparked curiosity in minds for centuries, pushing the boundaries of our understanding and imagination. The universe, in all its grandeur and mystery, is a cosmic ballet of stars, galaxies, and celestial bodies, performing an age-old dance choreographed by the laws of physics and time. Our universe is a treasure chest of wonders, a realm so vast that it boggles the mind. It's a tapestry woven with countless celestial bodies, each with its unique story. From stars that outshine our sun 1,000,000 times to galaxies swirling in the abyss of space, their light has journeyed across the cosmos for billions of years before reaching us. Imagine the scale of this vast cosmic ocean. It's so immense that even light, racing at a speed of over 186,000 miles per second, takes billions of years to cross it. And that's just the observable universe, the part we can see. There's a whole lot more out there, shrouded in mystery, waiting to be discovered. The universe is not just about the grand scale, though. It's also about the minute details, the tiny particles that make up everything we know. It's a cosmic jigsaw puzzle where every piece, from the smallest atom to the largest galaxy, fits together to create the grand spectacle we see. As we delve deeper into the cosmos, we find that the universe is filled with enigmas that defy our understanding. Dark matter, black holes, the nature of time and space, the possibility of parallel universes, and the ultimate question, are we alone? These are the mysteries that beckon us, that challenge us to venture further, to seek answers. Our journey into the universe is not just a quest for knowledge, it's a voyage of discovery, of wonder, and of awe. It's about understanding our place in the cosmos, about realizing how precious and unique our little blue planet is in this vast cosmic sea. As we embark on this cosmic journey, prepare to be amazed by the mysteries of our universe. Can you fathom the sheer size of the universe? Imagine trying to measure it, not in miles or kilometers, but in light years. The distance light travels in a year, moving at a mind-boggling speed of about 186,000 miles per second. Think about our planet Earth, a vast sphere of life with a diameter of nearly 8,000 miles. It seems immense, doesn't it? But when compared to the grand scale of the universe, our world becomes a tiny speck of dust, almost insignificant. Now consider the sun, our radiant star. It's over 100 times the diameter of Earth. If the sun were the size of a beach ball, Earth would be no more than a small pebble. But wait, there's more. Our Milky Way galaxy is so large that even light, traveling at its tremendous speed, takes about 100,000 years to cross from one side to the other. And the Milky Way is just one of an estimated 2 trillion galaxies in the observable universe. That's right, 2 trillion galaxies, each filled with hundreds of billions of stars, many with their own planets. And we're still not done, because the universe is still expanding, becoming ever more vast with each passing second. It's estimated that the edge of the observable universe is about 46 billion light years away. That's the distance light has traveled since the Big Bang some 13.8 billion years ago. Beyond that, there's even more universe, stretching out into the unfathomable depths of infinity. The enormity of the universe is, quite literally, beyond our human ability to fully grasp. It's a scale so immense that it can make our everyday concerns seem incredibly small and inconsequential, but don't let that unsettle you. Instead, let it fill you with wonder and awe. The universe's vastness is beyond human comprehension, and yet we are a part of this cosmic wonder. We are each one of us a tiny integral piece of this unimaginably vast cosmic puzzle. Imagine traveling at a speed of 299,792 kilometers per second. Now that's a mind-boggling speed, isn't it? It's so fast, in fact, that it's the ultimate speed limit in our universe. Yes, we're talking about the speed of light. The speed of light is more than just a number. It's a fundamental constant of nature that plays an essential role in much of the physics that governs our universe. But what does it really mean? Well, at this phenomenal speed, light can circle the Earth approximately 7.5 times in just 1 second. But here's where things get truly fascinating. We often use the speed of light to measure cosmic distances. This concept is known as a light year, the distance that light can travel in 1 year. It's about 9.5 trillion kilometers. Now let's put the vastness of our universe into perspective. Even at the extraordinary speed of light, traveling to our closest neighboring star, Proxima Centauri, would take over 4 years, and Proxima Centauri is just a stone's throw away in cosmic terms. What about the Andromeda Galaxy, our nearest spiral galaxy? Buckle up, because at the speed of light, you'd be on the road for a staggering 2.5 million years. So the next time you gaze up at the stars, remember this. When you see a star's twinkling light, you're not seeing it as it is right now. You're seeing it as it was when that beam of light began its tremendous journey through space. The speed of light, while seemingly instantaneous on Earth, is but a crawl in the grand scale of the universe. It's a humbling reminder that the universe is far larger and more wondrous than we can ever truly comprehend. What if we told you that most of the universe is made up of things we can't even see or detect directly? Now that's a thought that can make your head spin, isn't it? Welcome to the perplexing world of dark matter and dark energy. You see, when we look up at the night sky, we're only seeing a tiny fraction of what's out there. In fact, normal matter, the stuff we can see and touch, makes up less than 5% of the universe. That's right, less than 5%. What about the rest, you may wonder? Well, that's where dark matter and dark energy come into play. Dark matter, despite its ominous name, is no cause for concern. It doesn't interact with light or electromagnetic radiation, making it invisible and incredibly tricky to detect. Yet it's a significant player in the cosmic game, accounting for about 25% of the universe's mass energy. Its gravitational pull helps hold galaxies together and influences the path of light, giving us a cosmic peekaboo called gravitational lensing. Now, if dark matter is the cosmic glue, dark energy is the ultimate party crasher. This mysterious force makes up a whopping 70% of the universe and is responsible for its accelerated expansion. Imagine a balloon inflating at an ever-increasing rate. That's our universe on a cosmic scale, thanks to dark energy. Both dark matter and dark energy are elusive, and we know them only through their effects. Despite our best efforts, they remain shrouded in mystery, like a cosmic whodunit that's got the best scientific minds scratching their heads. But that's the beauty of it, isn't it? The universe is like a never-ending mystery novel, with each chapter more fascinating than the last. As we delve deeper into these invisible phenomena, we're not just exploring the universe, we're exploring the very nature of existence itself. Dark matter and dark energy, the invisible architects, shape our universe in ways we are just beginning to understand. The journey of discovery is far from over, but one thing's for sure. The universe certainly knows how to keep us on our toes. Are we alone in the universe? This question has captivated mankind for centuries. As we gaze up at the starry sky, we can't help but wonder if someone or something might be gazing back at us. Enter the Drake equation, a mathematical formula that tries to estimate the number of civilizations in our galaxy with whom we could potentially communicate. Named after its creator, Dr. Frank Drake, this equation takes into account factors like the rate of star formation, the fraction of stars with planetary systems, and the average lifespan of a technologically advanced civilization. But despite its mathematical elegance, the Drake equation is more of a tool for sparking discussion than a precise number cruncher. The values for most of its factors are still a matter of ongoing research and debate. This brings us to the Fermi paradox. Named after physicist Enrico Fermi, the paradox is the contradiction between the high probability of extraterrestrial life and the lack of contact or evidence for such civilizations. If there are a multitude of advanced civilizations in the galaxy, why haven't we heard from them? Are they too far away? Are they avoiding us? Or perhaps are we simply not listening in the right way? The search for extraterrestrial intelligence, or SETI, is an ongoing scientific endeavor aiming to answer these questions. It uses powerful telescopes to scan the cosmos for signals that might indicate the presence of intelligent life. While no definitive evidence has been found yet, the search continues, fueled by our innate curiosity and desire to understand our place in the universe. So, are we alone? We don't know yet, but every day we're learning more about our universe and the possibilities it holds. With each new exoplanet discovered and every signal scanned, we come a step closer to answering this profound question. The question of life beyond Earth remains one of the greatest mysteries of our universe. But isn't the pursuit of such mysteries what makes our journey through space and time so incredibly fascinating? What happens when a star dies? This question has been the starting point for many curious minds, leading to the discovery of one of the universe's most fascinating and terrifying creations, black holes. When a star has exhausted its nuclear fuel, it collapses under its own gravity. If the star is massive enough, this collapse results in a black hole, a region of space where gravity is so strong that nothing, not even light, can escape its pull. Imagine a cosmic vacuum cleaner so powerful, it's capable of swallowing stars, dust, gas, and any unfortunate space debris that strays too close. Now, let's take a moment to talk about a rather peculiar term, spaghettification. Sounds like a fun pasta party, doesn't it? Well, not quite. If you were to approach a black hole, the difference in gravitational pull between your head and feet would stretch you out like a strand of spaghetti, hence the term. Not exactly the most pleasant way to go, but certainly an interesting one. Inside a black hole, all these stretched out particles eventually reach a point known as a singularity. This is where the laws of physics as we know them cease to apply. It's a point of infinite density and almost zero volume. How can this be? Well, that's one of the many mysteries surrounding black holes. Some theories suggest that singularities could be gateways to other universes or dimensions. Others propose that they might be the birthplace of new universes. Yet, these are all just theories. The reality is, we know very little about what happens inside a black hole. Black holes, the cosmic graveyards, are just another testament to the universe's awe-inspiring mysteries. So the next time you look up at the night sky, remember the invisible powerhouses lurking out there, silently shaping the cosmos. They remind us of how much we've learned about the universe, but more importantly, how much we have yet to discover. Is our universe unique or just one among many? This question leads us to the concept of the multiverse theory, a proposition that has turned the scientific community on its head. Imagine, if you will, that our universe is not the only one. Picture an infinite number of universes, each with its own laws of physics, its own galaxies, stars and planets. This is the premise of the multiverse theory, an idea that has its roots in the mathematics of quantum mechanics and string theory. The concept of the multiverse emerged from the peculiarities of quantum mechanics, where particles can be in multiple places at once. Scientists started to wonder if this could apply to entire universes too. Meanwhile, string theory, another frontier of theoretical physics, also hinted at the existence of multiple dimensions and universes. Instead of the three dimensions of space and one of time that we're familiar with, string theory postulates the existence of 10 dimensions. The implications of the multiverse theory are profound. It challenges our understanding of reality and existence. It proposes that there may be universes where the laws of physics are completely different from our own. There could be universes where time runs backward or where gravity pushes instead of pulls. There might even be universes where things that are pure fantasy in our universe, like magic or dragons, are as real as the air we breathe. And what about us? Are there universes where different versions of ourselves exist, leading completely different lives based on different choices we've made? The possibilities are as endless as the universes themselves. It's important to note, though, that the multiverse theory remains speculative. While it's a fascinating idea supported by some aspects of theoretical physics, we don't yet have any empirical evidence to prove it. Yet the allure of the multiverse theory lies precisely in its speculative nature. It invites us to dream, to imagine, to wonder about the endless possibilities that could exist beyond the boundaries of our universe. The multiverse theory, while still speculative, opens up a realm of endless possibilities. How did the universe come into existence and how will it end? This, my friends, is the question that has perplexed the greatest minds of our species. It's a story that begins with a bang, the Big Bang to be exact. About 13.8 billion years ago, our universe was but a hot, dense, infinitesimal point. Then in a flash of energy and matter, it began to expand at an incredible rate. This event, the Big Bang, is the widely accepted theory of our universe's birth. But what about its death? Well, there are a few theories about that. Let's dive into them, shall we? First, there's the Big Freeze. This is based on the observation that our universe is constantly expanding. As it expands, the stars will eventually burn out, galaxies will drift apart, and all matter will decay. The universe will become a cold, dark, and lifeless expanse. A chilling prospect, isn't it? Then we have the Big Crunch. Imagine if the universe's expansion suddenly halted and reversed. Everything would start hurtling back towards the center, compressing into a singularity just like before the Big Bang. Some even speculate this could trigger another Big Bang, creating a cyclical universe of eternal birth and death. Finally, there's the Big Rip. This theory suggests that the universe's expansion isn't just continuing, it's accelerating. If this acceleration doesn't slow, it could eventually tear apart galaxies, stars, planets, and even atoms themselves. The universe in this scenario would effectively be ripped to shreds. So which of these is our universe's fate? The truth is, we're not sure. We're still trying to understand the complex and mysterious forces that govern our universe. The birth and death of the universe, like everything within it, follows a cosmic cycle of creation and destruction. Whether it's a big freeze, a big crunch, or a big rip, in the end, it's all part of the grand cosmic dance. A dance that for now continues to captivate and confound us. What is our place in this vast universe? Well, let's delve into that. The cosmic perspective is not just about understanding the universe, but it's also about understanding ourselves. It's a mirror that reflects our existence against the backdrop of time and space, offering a humbling view of our tiny corner in the cosmos. When we gaze at the stars, we're not just looking at distant celestial bodies, we're observing a cosmic history, a timeline that stretches back billions of years. Each star, each galaxy, each nebula is a chapter in this grand cosmic narrative, and we, as curious observers, are part of this unfolding story. Yet with this understanding comes a profound responsibility. Our planet, Earth, is but a small speck in the cosmic ocean. It's our only home, a precious oasis in the vastness of space. When you consider the sheer scale of the universe, our quarrels and conflicts seem rather small, don't they? Understanding the universe helps us appreciate the fragility and uniqueness of our planet. It heightens our sense of responsibility to protect it, to ensure its survival for future generations. It's not just about conservation, but about coexistence. The cosmic perspective also underscores our potential. We are a species that has gazed at the stars and dared to understand them. We've deciphered cosmic mysteries, ventured into space, and even left our footprints on the moon. Our curiosity is boundless, our thirst for knowledge insatiable. As we continue to explore the universe, we are also exploring ourselves, our capabilities, our potential. So, what is our place in this vast universe? We are tiny, yes, but we are not insignificant. We are explorers, dreamers, storytellers. We are the universe experiencing itself, understanding itself. In the grand scheme of the universe, we may be small, but our potential to understand and explore is limitless. What lies ahead for us in the exploration of the universe? Ah, the final frontier, a realm of endless possibilities and unanswered questions. As we stand on the precipice of the future, our eyes are drawn ever outward to the stars, the planets, the galaxies that lay beyond our reach. The coming years promise a plethora of exciting missions. We're talking about the likes of NASA's Artemis program, aiming to return humans to the moon, this time to stay, transforming it into a springboard for Mars and beyond. There's also the James Webb Space Telescope, the successor to Hubble, ready to peer deeper into the cosmos than ever before, unearthing secrets from the universe's infancy. But the ambitions of humanity don't stop within our solar system. No, we're setting our sights on interstellar travel. The concept may sound like science fiction, but projects like Breakthrough Starshot are turning it into science fact. This initiative aims to send a fleet of miniature spacecraft to our nearest stellar neighbor, Proxima Centauri, propelled by powerful laser beams. If successful, we could receive images and data from another star system within our lifetime. And let's not forget the potential of the warp drive. Yes, you heard that right, the famous Star Trek propulsion system. While still purely theoretical, scientists are actively exploring the concept, which could, in theory, allow us to travel faster than light by warping the fabric of space-time. The journey won't be easy, of course. There will be challenges, setbacks, maybe even tragedies, but the potential rewards, they're beyond comprehension. The chance to discover new worlds, to uncover cosmic secrets, to answer that age-old question, are we alone? As we gaze into the cosmos, we're not just looking at stars and galaxies, we're looking at our future, our destiny. The universe, our final frontier, beckons us to explore and understand its depths. The call to adventure is strong, so let's dare to venture into the unknown, shall we? After all, as a wise man once said, space, the final frontier, these are the voyages of the Starship Enterprise. Oops, sorry, got carried away there. The universe, our final frontier, beckons us to explore and understand its depths. Our journey across the universe comes to an end, but the journey of understanding and exploration continues. We've traversed the vast expanse of the cosmos, from the concept of light speed to the enigma of dark energy. We've pondered life beyond our blue sphere and peered into the abyss of black holes. We've entertained the possibility of multiverses and witnessed the birth and death of our own universe. In this grand cosmic theater, we've seen that we are but a small part of a larger, more complex narrative, yet our curiosity and thirst for knowledge propel us forward, pushing the boundaries of our understanding. Our universe is a treasure trove of mysteries waiting to be unraveled, a cosmic canvas where every star is a story, every galaxy a testament to the beauty of existence. Remember, we are a part of this grand universe. Keep looking up, keep wondering, and keep exploring.